What an awesome screen. Hello, everybody. It's awesome to actually be able to be at a conference where I can actually see the people I'm talking to, rather than just talking to this tiny camera in front of me. So welcome, and thank you for joining me here. Now, over the last few years, there have been a lot of awesome new technologies created that have allowed us to deploy applications far easier to the web. We can build a Spar application for the front end. We can host those static files. For today, we're going to be looking at Blazor WebAssembly to do this. And for the API, we have functions that can either be Lambda functions, Azure function, Google Cloud functions. And joining those together, we have a pretty simple way of making really rich, dynamic applications. Until recently, though, deploying those in a simple way wasn't necessarily straightforward. I'm going to go for the Azure stack here. In order to get your static web app out, you would have a storage account and turn on web apps. And for your API, you're going to have Azure functions, but that's also going to mean you're going to need a second storage account, you're going to need an app service plan, and the function app itself. And because they're running in different locations, you're either going to have to put them behind a gateway, or you're going to have to implement cores inside your application so they can communicate. Not necessarily the easiest thing. My simple application now has 5 Azure resources. Now, for the last 12 months, we've had a better way of doing this: Azure Static Web Apps. Inside of one single Azure resource, we have our static files, which are globally hosted for availability around the world. We have Azure functions, and we have this little bit of glue in the middle that joins them together and makes it appear that we just have one cohesive application. Hi. I'm Stacey Cashmore. As said, I am Tech Explorer DevOps at Omniplan, a financial advice software company in the Netherlands. I have been developing software since the middle of the 1990s, and for the last 2 years, I've been honored to be able to call myself a Microsoft MVP in developer technologies. Now, one issue that we do have with these Azure Static Web Apps is when it comes to actually make our application. Because all of that complexity that the Azure Static Web App takes away, we still have inside of our development environment. We don't have that magic glue that turns everything into one coherent application. We have one application that's running on one port, and we have our Azure functions that are running on another. When they were first released in preview, the only way you could actually debug these was to add special code to trick the computer when you're running locally. But thankfully, over the last few years, we've had the Azure Static Web App CLI, which went into general availability version 1.0.1 just a couple of weeks ago in May. So what we're going to do today is take a look at how we can use this Static Web App CLI in order to debug our applications and see how we can run things locally. Now, that's enough of me talking. Let's have a look at some code. So the first thing that I want to show you is a couple of applications that we're going to be using today. Now, these are really simple applications. It's just an out-of-the-box Blazor application with a little bit of a change. It goes to a Cosmos DB via an Azure function, loads some blog posts, and just allows us to get things on the screen. In Azure, that runs fantastically. Let's run it locally. So I have Visual Studio here. And the first thing that we're going to need to do when we run it is make sure that everything is actually running. So if we go into our solution and we go to the startup projects, we need to start multiple projects when doing this. So we have the API starting and we have the client starting. Let's see what happens. We'll click the Go button, and we'll wait for that to come up. So we have to hope that it compiles. It compiled 5 minutes ago, so it should be OK. There we go. Here's our application, which looks rather good. Here is our Azure functions. So everything is running. But now, like I say, if I go to my blog post, I'm going to get that error message, because nothing is able to talk to each other. if we now go to a different terminal and we run the static web app CLI. So the static web app CLI, you access it via the SWA command. You can install this via npm. And it's got lots of functionality that it can do for us. It can log on to Azure. It can deploy static web apps. The one that we're going to concentrate on here is just running it locally. So that's SWA start. Then we need to give it the URL of our application. So my application is running on localhost 5000, if I remember correctly. Now, what this static web app is going to do is any request that comes into the Node.js server, which the static web app will start for us, it's going to pass that through to localhost 5000, except for those URLs that are included in that special glue that we get inside of an Azure static web app. So things like the API, that's going to get ported by default to 7071, which is where Azure functions generally run when you're doing it locally. So now if I go back to my browser, and I open up a new tab, and I learn how to type, if I go to localhost 4280, it takes a little bit of time to load because it's having to proxy everything through my CLI, but there it is. And now when I click on my blog posts, fingers crossed, we get some data out of there. So we can now run our application locally with just one simple command. This gives us a few other fun things that we can do with it. So if we come into Visual Studio, we can, if we open up a couple of files, set some breakpoints. So let's break inside of our API. And then let's break inside of our Blazor application. So inside the blog post summaries, we're just going to do about here. So now if I go back to my application and I do a refresh, I should hopefully hit a couple of breakpoints as I go through. There's the first one. So this is inside of my Blazor application. So we can debug Blazor inside of here. We can see what is the content of all of our variables. We can check when things go boom. And then if we click Go, we go onto the API. So we can have breakpoints to really get into the depth of our applications using this functionality. Now, there is an interesting one here. Because I'm using Blazor, I ran this application via the browser that Visual Studio opened. If you do this via any other browser, you won't hit your Blazor breakpoints because it doesn't have that tunneling from the WebAssembly inside of the browser back to your Visual Studio. The other one that we get when we do this is we have hot reload by default. So if I go back into Visual Studio and I go into my summary page and get rid of some screens that are taking up space, if I change my title here, because I forgot my exclamation marks because I love exclamation marks, and we do a hot reload, we should be able to see in our browser, if Visual Studio lets me change back to my browser. There we go. We now have our exclamation points without doing any reloading of the page. So this really speeds up the developer in a loop when we're working with these technologies. So that's what we can do inside of Visual Studio. But there's going to be times when we don't actually want to run it inside of Visual Studio. If you just want to run your application to look at something, or if you're not using Blazor, but you're using Angular, Vue, React, then you're going to need a command line to run this instead. So what we're going to do here is we're going to run the same application, only we're going to run it on the command line. So we're going to do .NET Watch run for our client. We're going to do func start for our function. We're going to hope that this opens up quickly enough. There we go. And then we get our application. Obviously, that's not going to work on the tab that's opened up by .NET Watch run. But if we go back to localhost 4280, we still get our application. And it's still running even though we've not done anything to that static web app CLI terminal tab because it's just listening for certain ports, and I'm using the same one on the command line as I am inside of Visual Studio. However, I'm now running 3 tabs, and that's kind of annoying. So the next one that I want to do is see how we can get from those 3 tabs down to just 1. And the static web app CLI allows us to do this by also running the functions for us, and it will also allow us to set a startup command for our client application so we can get everything in one place. So I'm just going to clear up this screen a little bit. So we've got a command here. It's still SWA start and then that localhost 5000, but now we've got an API location parameter at the end of it. What that's going to do is tell the static web app CLI to look in this folder and just run whatever functions you find. It doesn't matter if they are TypeScript functions, PowerShell functions, .NET functions. It will just run those for you and make them available. And then I've got this -- run at the end. And this is that startup command for the static web app CLI, how we're going to get our development server running. So if we start this one now, first of all, it's going to build our projects. Then it should build our API. And then we have that 4280 available to us yet again. So that's just one command. It's a bit bulky, but we'll get to that in a minute. The next thing that I want to look at just really quickly is authentication. So in my original applications that I had one, which is just simply reads data. And then I have another one, which allows me to log in using Twitter. This is a point when my network breaks. No, come on, you can do it, little computer. So we log into Twitter, we come back to our application, and I'm now authenticated, and I'm authorized to do things inside of my application. Azure Static Web Apps do this all for you. There's no authentication steps that I have to take myself. I just use the Static Web App authentication. It's that glue. That's also a problem when running locally, because Azure Static Web Apps are registered with Azure Active Directory, GitHub, Google, and one other one, Twitter, the one that I used. So we don't have that locally. We are not registered with those providers. Thankfully, it does actually have us covered here as well. So what I want to do is change out from my read project. I'm going to come into my auth project, and I'm going to rerun that same command. So this is now going to start my second application where I need to be able to log in and see things as they're working. So let's go to localhost. Let's learn to type. $42.80. So now when we log into Twitter, we get this new page. And what the Static Web App CLI does, it just completely hides all of that authentication stuff that you don't need to do because it's taken care of by Azure, and it fakes it for you. What this means is that we can have a user, test user 1, and we can log in with that. We're just going to give this user the standard user roles that you have, which is anonymous and authenticated out of the box for every user that logs into a Static Web App. And now when we log in, well, actually, I still can't do anything because I don't have rights to do anything. But we can add those rights really easily. And this is actually something I really love about coding with authentication and the Azure Static Web Apps. Without having to have a user in each of the social networks that we want to support, or if you're in an enterprise environment, without having to have a test user in every single system that you want to authenticate against, we can test different roles, different capabilities on the fly without the bureaucracy, which is generally involved in getting the right test users so you can run your application. So if we log in now, we can come in, we can go to our blog post, and we have this little create button available, edit button, so we can change things and move on. The other thing that we can do here is, with much more ease, we can share our users between our development team. Because we're not having to share username and passwords, which of course we would never do, we can now just share the username and give an amount of data behind that. We can still give that user different rights to different capabilities, but we can all share the same user without sharing passwords around the place. Much safer. The next step that I want to take a look at is static content. Because so far, what I've been doing when I've been running this application is, even though I'm deploying static files, it's still running inside of .NET Watch Run. So it's still got that Kestrel server behind it. This means it is not the same as you're running production. And there are differences that can catch you out and make you pull your hair out. Don't do that. Do this instead. What we're going to do is actually run our static web app against some published data or some published code so that we can test it really with those static files. So let's stop this. And we're going to do our SWA start. And we're going to look at our distribution folder and the www root. And then we want -- API location. I'm typing blind here, so I hope this is going well. Is /API. Nope, that did not go well because I made a mistake. Oh, come on. Sorry, I've got a little clock on my second screen here, so I don't quite see the whole screen. That looks better, hopefully. So now this is serving static content. We are no longer going out to our dev server URL. We are just looking at pure files. We are still running against the same API, though. So if we open up our file, we're now loading our production distributed content, and we can still do all of the same things that we did before. This is a really nice one to check that you've got things like navigation fallbacks in place so that if a user's on blog post and they hit refresh, it does actually reload the page. Out of the box, it doesn't do that. You need to make sure that you've got your routing in place for the Azure Static Web App to make sure that this happens. Right, final thing that I want to look at today is the static web app CLI. Now, I've already said that some of these commands can get a little bit long and they're a little bit tricky, and you don't necessarily want to have to remember that all the time. The other thing is, if this is on a public repo, you want to give the people accessing your repo a really easy way of running your application. Now, with the static web app CLI, what we can do is set up a configuration so that users have really simple commands that they can run to get everything going. So for that, we're just going to start up VS Code. And of course, it's going to start up on the wrong screen. And we have a file here, swacli-config.json. And inside here, we've got two different routes, two different ways that users can run the application. The first one is serving static files. So there we say the app location is that distribution folder. And the API location is just that /API. And the second one, we're running that full-blown app dev server URL with that .NET Watch Run command started before we begin. So if we come back to the command line now and do SWA start static, it's going to tell us that it's picked up the configuration static from our file, and it's going to run everything as it did before. And everything should be working as we expect it to. And then, of course, lastly, just to prove to you that it does work, we're going to do SWA start run all. And this is going to pick up that run all configuration, and it's going to fire that full-blown dev server that we've seen before. So this is just a nice one. You can put this in your README in the beginning, just SWA start static, SWA start run all, and you can get people running out of the box instantly with your application. Ta-da. So this is a really quick runaround of Azure Static Web Apps, or the CLI for Azure Static Web Apps. On the screen right now is a QR code. No, it's not, because my computer's doing weird things. There we go. This QR code will take you to the GitHub repo of the Azure Static Web App CLI. It's open source. You can see how it's built. If you see any problems with it, you can make pull requests. It is a community-driven thing, so please help out there. You can also look at the Microsoft Learn documentation That's also got loads of information about how you can run this and about how you can run static web apps in its fullness. I've been Stacey Cashmore. Thank you so much for your time today. Enjoy the rest of the conference.
Thank you, Stacey. That's been interesting seeing web development other than JavaScript.
Yeah. It's the nice one with Blazor is if you're a C# developer, you can still do some front-end development. I'm not going to say one's better than the other, but you've got options now.
Have you also, or do you also code in JavaScript?
I do code in Angular. That is what we use in the office mainly. We've got one little tiny Blazor app, but yeah, we run a lot of JavaScript too.
Okay, and do you see some like advantages, disadvantages of one or another when you code, developer experience or something?
I think getting started in Blazor for me personally is faster, but yeah, I'm a C# developer. So that one is really, for me, that helps me get started out of the block. Whereas I think if you're used to React, then I think just go with what you know and go with what works best for you. It's always worth taking a look, of course.
Yes, of course. All right, there were no questions from the audience. If someone has a question, just raise a hand. No, okay. Yes, that will be everything for this morning. We will resume the program